this base is equal to this base, which is great because then all I have to do is set the powers equal to 0 and solve. We also talked about how, okay, maybe the bases don't exactly line up. Maybe I have something like this. 81 is equal to 3 to the x plus 2. Okay, now I can't use the trick immediately. One has a base of 3, one has a base of 81. But if I'm careful about what 81 is, or I'm aware of what 81 is, it's 3 to the 4th, which actually is probably maybe a little bit above the scope of what I would accept or expect. Then what I do here is now that I've changed, yeah, is anyone else having Zoom issues, or is that just Piper's email or her Zoom? Is everyone else good hearing me? Am I choppy or anything? Okay, cool. Good. Yeah, you might just want to leave and yeah, exactly. Relaunching the meeting almost fixes everything. Honestly, if that doesn't work, you can restart your computer, but I apologize, nothing worse than a terrible Zoom. Anyways, with this small adjustment, now I can use the trick again. So I have 3, they're the same, set the powers equal to 0 and solve. Nothing really too terrible there again. But sometimes there just isn't really a nice trick for that. Sometimes we have like 5 to the 4th. There's nothing that I can do to 5 to the 4th to make it related to the power of 3 and vice versa. And so what we do to kind of deal with this and adjust for this, because we want to be able to actually solve for x always, is we introduce this idea of a log. And well, what's a log? Logs are not the easiest of concepts. Not everyone's super crazy about it. But what they are is they're inverses of exponentials. So like when I have x plus 2 is equal to 4, how do I solve it? I subtract 2 from both sides because addition and subtraction are inverses of each other. Same with multiplication and division. When I'm solving those problems, those are inverses of each other. And so that's what a logarithm is. I think that is part of the problem people struggle with logarithms is we don't have any concept of what this actually is, what to tie it down to. Well, it's the inverse of an exponential. And so if I want to solve something like this, if I want to solve something that has a power of x, I need a logarithm to undo this 3 essentially to make it so I can actually solve. And vice versa, obviously. If something's an inverse of something, the reverse is true. We've also seen that. So logs are inverses of exponentials and exponentials are inverses of logs. Okay, that is the introduction. But for starters, we're not going to really get in too deep into what logs are just yet. And honestly, unfortunately, this section is kind of here's an introduction to log. Here's some cute little properties about them. And then we kind of just make you take the exam. And then we'll actually go into, okay, now we can get into the meat of the things. We can actually solve things and apply them and see how these actually work. So before we get into anything, it's important to kind of speak the language, to translate things. So if I have something like this is called exponential form because, surprise, surprise, I have an exponential over here. If I want to translate this into a logarithm, what I do is I take this base, this 3, and I'm going to undo him. Well, to undo him, I'm going to use the inverse, and I'm going to use the inverse on both sides. And so the left side of my equation will become log base 3. Sometimes we like to put in parentheses. You don't necessarily have to if you're good with writing. 81 is equal to 4. So I move the base to the other side. It becomes the log of my base, or the base of my log, and then I just drop the power down. And that's how I convert any exponential to a logarithm. So if I am undoing this base, if I'm undoing this exponential, and let's say I want to solve for whatever this power is, I just take this base, move it over, and slap a log on it. So someone help me convert this. It's an exponential. Let's say I want to solve for x. How do I translate this equation into something that has a logarithm?
Would it be log base b of y equals x?
Yeah, I would do it in the other order, but they're exactly the same thing. So my base of my exponential was b, so the base of my new log has to be b as well. And then I shuffle the log to the other side, take the, that doesn't look good. Oh, I guess I'll just put a parentheses on to make it clear. I move it over to the other side, and then I drop down my power to make it x. Perfect, yes. And that's, again, a translation. Why are we doing these weird translations? It'll become a little bit more evident when we get deeper into logs. But for starters, we have to understand. We have to speak the language of how is one related to the other. Okay, and so sometimes I want to do the reverse. Sometimes it's nice to solve for x by I want to get the x in the power by itself. Sometimes this is pretty hard to conceptualize. My base is x. I want to solve for x. Let's say maybe I'll change this, adjust this slightly. This is a pretty hard question as is. And so in this logarithm form, don't really know how to solve, but maybe I can convert it to an exponential. And the conversion is pretty similar to the converting to a log, which makes sense because, again, kind of hammering this concept home. Logs are inverses of exponentials. So to convert this into an exponential, my base here is the x of my logarithm. Now I move this to the other side, and then I'm going to convert it into an exponential. And my exponential would be x gets moved to the other side. So it's going to be x to the fourth on the right side of my equation. And now the 3 gets left by himself. I've isolated the 3. And now I can solve this. Now it becomes a problem that was almost unsolvable, at least visually, to something that now is kind of one step away from being able to solve. So it's not always the best to put it into a logarithm. It's not always the best to put something into an exponential. And so we want to be able to do both. Okay. So how do I convert this into an exponential?
You move the b to the right, and the exponent would be 2.
Yep. So I move the b to the right, exponential will be 2, and then I leave the input of the logarithm by itself. Sometimes we call this the input. Sometimes we just say log b of 4, but essentially it is a logarithm is almost like a function. You would plug it into a logarithm and get a result. So we can't just get rid of the 4 or anything like that, or multiply the 4. We have to kind of convert before we can do anything inside this function. Any questions about that? Cool. It's a weird stuff. I'm fully aware logarithms are a weird concept. A lot of people don't have a lot of experience with it. So obviously the first time you see it, it's going to be terrifying. Once you start to get good at step 1, make sure you feel comfortable with translations before moving on to something else. Then instead of kind of jumping in at the end of, oh, here are all these properties and we're combining and we're stretching and we're shrinking and all of this stuff, you need to feel comfortable with this so you get this entry of what a logarithm is. Okay, so sometimes like this is actually true. Log base 3 of 81 is 4 because 3 to the 4th gets me 81. And so I could throw this in my calculator. That is, if you have a fancy calculator, even not really that fancy, which we'll talk about later, throw this into your calculator and find, okay, indeed log base 3 is 81. Another way to kind of think about this is 3 to what power would get me 81? Well, that's 4. But this isn't always the case. Let's say I have log base 3 of 11. I don't really know what that is. I would have to use my calculator. It won't be a very nice number. But there are certain logs or certain tricks that kind of give us an immediate, fairly nice answer. So these are all kind of properties that if you know the properties, maybe you put them on like a note card and you see these questions, you say, oh, I know how to do that. This is your answer immediately. You don't kind of have to overthink of, okay, well, how do logs work again? And let me grab my calculator. And did I put it in my calculator? Because it is a little bit weird. It's not the easiest of things to throw into it. With these, you can just look and say, yep, boom, there's the answer. So log base 21 of 1, this is something that always gets a result. Specifically, if I have an input of 1 in a logarithm, I always get something back. But let's get into the why of it. So if I have a logarithm and I'm trying to evaluate it, it's hard to see it in this form. Log base 21 of 1. Again, there's a shortcut to it, but let's pretend that there isn't a shortcut to it. How I solve it, or how I would recommend solving it, is saying, okay, I don't really know what this is yet. So I'm going to put like a placeholder variable of, okay, what's x going to be at the end of the day? And once I have that placeholder variable, well, I can convert just like I did. That's not the button I want to push. I can convert just like I did. Oh, no. What have I done? Oh, I see. My magnifier is maximized to 200. That was weird. Okay, resolved. Good to know. Don't hit those 2 buttons. So I could convert this. I want to translate this into an exponential because typically people feel a little bit more comfortable with an exponential than a log. I know I do. So if I turn this into an exponential, now my question becomes, what power can I take 21 to get 1? Does anyone know what power that is?
0.
Yep. Anything to the 0 power gets me back a power of 1. And so, did I do something wrong again? No, it's doing that weird magnifying thing. And so I know that x is equal to 1. Sorry, x is equal to 0. And in fact, this is kind of a nice log property. Log, let's say I don't really know what my base is. Any base whatsoever. It could be log base 1,000,000,000, could be a log base 10, could be a log base 3,000. Any log, if my input or the inside of my log is 1, it's always going to be 0. So again, this is the y of it. If you want to do the y of it when you're working through like the exam and say I want to always show my work, great. But this is an accepted property. Regardless of what my base is, if my input is 1, I will get a result of 0. Now, similar concept to the second question, log base 21 of 21. Well, if we want to be extra careful, if we want to understand the y of this property, well, let's convert it again. Let's say I don't really know what this is equal to. Let's put a placeholder of x. Yes, this is the final answer. Or honestly, you could just write 0, I suppose. I put a placeholder of x, so there was no x in the original equation, but you could write it like this, I think would be the proper way of doing it, but either way is fine. Okay, so what does this equation translate to as an exponential?
(21) equals 21 to x.
Okay, and now we kind of think to ourselves again, okay, 21 to what power gets back 21? What would I have to take that power to return the exact same result?
1.
Yep. So the property here is that if I have my bases matching up, then I'm always going to return a value of 1. Log base 10 of 10 is 1. Log base 50 of 50 is 1. Log base 5 billion of 5 billion is always going to return a value of 1. So again, if you want to go through the process of solving this, want to make sure you show your work, that's great. Honestly, if you know your properties, you've written them on the note card, I would give you full points if you just did that. It's kind of an accepted property of once you feel comfortable with logs, it's always just going to be 1 in this case. Okay, 2 more examples. Oops. Someone walk me through how to solve this.
8 equals.
So it
2
would
to the 8.
become log base 2 of 8 equals x,
Mhm. And then,
which then would become 2x equals 8. And then x should equal 3.
yep. And now I kind of play that game of this is where that coming or being aware of how exponentials work and being a little bit comfortable of like what's 2 to the third and what's 2 squared helps us. Okay, well, what power gets me 8? 2 cubed is 8. So x is equal to 3. This one isn't really a property. It's more of just a process of how to actually solve these. So this one you couldn't just automatically throw down 3. I mean, if you are really good at logs, maybe you can kind of glance at this and say what the answer is. I would argue that even if you are that good at logarithms, make sure that you can justify your answer of how did you actually get your x is equal to 3. I'm kind of sprinting through these. Are there any questions about these so far? Process isn't too terrible. Translate it, then you have to do a little bit of thinking. Okay, what do I take whatever to the power 2 to get the results? Once you get past that step, I would say that's the hardest step in the process. Boom, you've got your answer. And honestly, for these first 2, like I said, these are just accepted properties, so you don't even really have to solve these first 2. Cool. Okay, someone else. I think Mitch was the one who helped me with the last one. Someone help me with this one. This one's a bit tricky.
Set it equal to x.
And honestly, you could set it equal to y if you want to. It's a dummy variable is what we call it. So it doesn't really matter what we choose, but if you're comfortable with x, leave it as x. I'm just going to do y for the sake of, I don't know, doing y. Doesn't get enough respect.
1/4 equals 2 to the x power.
Now we play this kind of difficult game, and it becomes pretty difficult in this question. Honestly, as difficult as you will see on the exam. What do I take 2 to? What power of 2 will get me 1/4?
1/8.
1/8 is the
negative
8th
2?
root. So that's not quite right.
Would it be -4?
Closer.
Negative 2.
Yeah, it's -2. So two ways to approach this problem. First, I look at the denominator and I say, oh, it's 4. 2 to what power gets me 4? 2, great. If you ever see something on the opposite side of a fraction, that means your power is negative. So yeah, exactly right. Y is equal to -2. And honestly, the nice thing about logarithms is it's super easy to check your answer, right? Like if you can reason through and logic it and say, I think it's 2 or -2, well, just what's 2 to the -2? It's 1/4. Honestly, use your calculator on it. Why not? Same thing with this. I think it's 3, but let me go ahead and check it. Oh, 2 to the third gets me 2 times 2 times 2 gets me 8. Cool. And again, this isn't really a property. This is more of a process. When you see something on the bottom of the fraction, be aware that almost ignore it initially and say, okay, 2 to what power gets me 4, 2 squared, and then just slap a negative in front of it so it moves to the opposite side of the fraction. Okay, last one, and this is actually a property again, so maybe I should have done it as the third thing in the process, but whatever. Who was that? That was Austin and Mitch, so someone besides those two walk me through how to do this last one.
So you start off by setting it equal to x.
Perfect. In this case, it's important to not use y, right? Because y is already in the equation. So yeah, x is a good choice. Okay.
Then you put y cubed equals y to the power of x.
Mhm. So what's x?
Is it 3?
Yep. This is exactly the same concept we finished last class with. If these are matching up, if the bases are exactly the same, set the powers equal to each other. Boom. Maybe you'll have to do a little bit of solving, but in this case, you don't. They're the same power. Boom. X is equal to 3. Okay, and so that's our last log property. Specifically, it's going to be a little bit weird to say it this way, but if I have my input and my base the same, and then on my input there is a certain power, let's use X, then I just return the value of the power. So it's almost like I'm canceling them out. Well, it's exactly like I'm canceling out. So that is the kind of convoluted way of saying it. But really the way to logically reason through it is if I see two things matching up, well, boom, boom, they cancel out because, again, exponential is a inverse of a logarithm. Boom, boom, they cancel out. My answer is just the power. So what to take from this slide? 3 properties that if you recognize them, great. Honestly, you don't really have to write anything on the test, but the answer, if you want to be careful, maybe write the property. If you want to be extra careful, you can go through the process if you really want to, or let's say you just forgot the property. All that's perfectly fine. And then regardless, anytime you're solving a basic logarithm and even kind of a more complicated logarithm, step 1, translate it so we can deal with exponentials, which is typically easier than dealing with logs. And then just do that reasoning. Okay, 2 to what power gets me 8? For this test, I'm not going to give you something weird like, okay, 2 to what power gets me 10? Because there isn't, well, there is a power, but it's going to be a weird decimal and it's kind of hard to reason through with. We'll talk about how to maybe deal with this after the exam, but for now, it's going to be fairly straightforward. We're going to give you, the answer will probably be 3 or 2 or maybe 4, but we won't really go beyond that. We want to stick to this. Can you look at an exponential and then can you say, okay, what power will get me the other side? So if it's 4 to the x is equal to 16, that's a reasonable question for me to ask you because, well, 4 squared 16, I'd say that's fairly common knowledge. Okay, that's it for solving. We'll get into graphing once you practice these concepts for a bit. Are there any questions? If you're overwhelmed with this right now, I fully get it. Logarithms are really hard. They are notorious. They're probably the hardest concept that we cover kind of overall in college algebra. So I get it that it is difficult. That's why you need to lean on your partners more than ever to say, oh, okay, I kind of get these properties, but I'm messing up my trans